problem we have here is that 163,000 kilogram rocket is launched straight up and it generates a force of 5.2 times 10 to the 6 newtons. So basically, what we're trying to find is the speed at 561 meters. So notice that there is an external force this time, so we can't really use conservation of energy because this is not a closed system. So we can use our definition earlier. So work net equals the change of kinetic energy. So this rock is from rest, so just the work net is just the kinetic energy final. So basically, since this is the network, we have to look at what forces are being acted upon the the rocket. So let's just draw a little free body force diagram. So we have the F thrust, and that's a lot. So we'll just call it F applied. And then we have gravity that's going straight down. So we're going to just take the net force. So that would be 5.2 times 10 to the 6 minus mg, so that's 163,000 times 9.8. So then that's going to give us a net force of some value, so let's just call it F net. So then we're going to take this value calculated, and then we're going to multiply it by the displacement, because and since since the displacement and the force are in the same direction, um, the so basically the angle that it is at is 0. So what I mean is, since since the force and displacement are completely parallel, that means the angle that the work goes through is 0. So it would be F net times delta x cosine 0. So, and then that would just simply be 1. So that is our net work. So what we can do is we could plug it back into the change of kinetic energy. So, and that's same thing as KEF, and then KEF is just 1/2 mv squared. So let's multiply 2 on both sides. So I'm just going to sub that in for W net. And then you get m times v squared. And then you divide m by both sides. 2 W net over m equals v squared. And then v would equal the square root of 2W net over m, which should be around 157.47 meters per second. One hundred 13-gram puck slides across ice, which is frictionless, at an initial speed of 1.9 meters per second. So then suddenly an air gun appears and exerts a 1.1 Newton force. Hold on. So I'll just write 1.1 Newton force on the front of the puck. So then the air gun is aimed 31.9 degrees below the horizontal. What is the final speed of the puck after traveling 50.3 centimeters? So this is what the puck looks like. So this is our puck. So it's being aimed at the front of the puck. So that means our gun would be like this. And then it would exert air right here, right on the front of the puck, at an angle of 31.9 degrees. So our displacement is right here, but our force that is parallel to the displacement, which is Fx, is going to the left. So that means that there's negative work being done. The puck is slowing down. So basically, you can write this as, so the work done, and there's no other forces going on that are opposing the puck. So that's the only force. So the net work is the same as negative F times delta X times cosine theta, right? Because you're trying to find the force that's parallel to the puck's motion, and the negative is there because it's opposite from the displacement, because the force is going to the left. So then we can apply this to the work energy theorem. So W net equals the change in kinetic energy so then we can rewrite this as kinetic energy initial and kinetic energy final, since it has an initial speed of 1.9. So W net equals K E F minus K E I. So, and these both can be rewritten. So W net equals, they both have the same mass. So 1/2 mvf squared minus 1/2 mvi squared. Alright? So what I'm gonna do is, so let's rewrite that. W net equals 1/2 mvf squared minus 1/2 mvi squared. So what I'm gonna do is I'm gonna add 1/2 mvi squared, or the initial kinetic energy, to both sides. So we get W net plus 1/2 mvi squared equals 1/2 mvf squared. So we're trying to find vf, the final speed. So what we're going to do now is multiply by 2 on both sides. So we get 2 W net plus mvi squared equals mvf squared. So then we're going to divide mass on both sides. So 2 W net plus over m over vi squared equals vf squared. And then we square root both sides. So then you get 2W net over m plus vi squared, which equals to vf squared. I mean v1. I mean vf, my bad. Alright. So that is our answer. So what that'll actually turn out to be is 1.33 meters per second.